In this video, I'm going to cover section 9.4, Measuring Weight from Contemporary Mathematics from OpenStax. The learning objectives of this section is to identify reasonable values for weight applications, convert units of measure as of weight, and solve application problems involving weight. So any discussion about metric weight must include a conversation about mass. So scientifically, mass is the amount of matter in an object, whereas weight is the force exerted on an object by gravity. The amount of mass of an object remains constant no matter where the object is in space. So the mass that you have on Earth would be the same mass that you would have on the moon is the same mass that you would have, say, on the, like Pluto, right? So that is your mass. Your weight, however, would be different because weight takes into account the force of gravity that is being exerted. So identical objects located on Earth and on the moon will have the same mass, but the weight of the objects will differ because the moon has a weaker gravitational force than Earth. It's further away from the sun, thereby giving it a lower gravitational force. So objects with the same mass will weigh less on the moon than on Earth. Since there's no easy way to measure mass in everyday life, the kilogram is used as a unit of weight because gravity is just about the same no matter where on Earth you go. So kilograms and grams, which we're going to talk about, the base unit gram, is a measure of mass. But it can also be used as a measure of weight, again, because gravity is just about the same no matter where on Earth you go. So let's identify a reasonable unit for weight here. So which is more reasonable for the weight of a newborn baby, 3.5 kilograms or 3.5 grams? So if you don't know, this is a good time to kind of point it out that a kilogram, so 1 kilogram is approximately 2.2 pounds. Okay, so 3.5 kilograms, we're looking at, over 6 pounds. And then 3.5 grams, remember, I think I've mentioned this before, but I'll mention it again. So 1 gram is about a paper clip, right? So if you think about that, babies typically are measured in pounds if they are at, if they're born at full term, right? So for a newborn baby, we're probably looking at 3.5 kilograms. So baby weighs more than 3.5 paper clips, as I said. So we're definitely looking at 3.5 kilograms is a more reasonable weight for a newborn baby. Now, here are some common conversion factors. We can still use all of our same conversion factors. Grams works the same, so keep her dancing because dancing creates marriages. Kilo, hecto, deca, base unit, deci, centi, milli, that all still is applicable here with the movement of base 10. So that would be multiplying by 10 going right, dividing by 10 going left. But it is very rare that you'll hear a decagram or a hectogram or, a centigram. The major ones are kilograms, grams, and milligrams. You also have one more, which is mentioned over here on the far right of the screen, and this is a metric ton. All right, so a metric ton is 1,000 times the amount of a kilogram. So 1,000 kilograms is a metric ton. So to go from metric tons, we would multiply. So to go from metric tons to kilograms, we would multiply by 1,000, and then to go from kilograms to a metric ton, we would divide. Because again, that would be like up here on this scale, kilograms to metric ton would move the decimal place actually move it 3, so this would be like 10 to the negative 3, because that's going to be 3 jumps to go to a metric ton. Kind of weird, but we do have something called a metric ton unit for weight. So how many kilograms are in 24,300,000 milligrams, right? So this one would be pretty easy just to look at our prefixes. So we're starting at milligrams, and we're going to go 1, 2, 3, 4, 5, 6 up to kilograms. So if we're starting at 24,300,000, so starting here at the end, we're going to go 1, 2, 3, 4, 5, 6. And so that's going to take us from milligrams to 24.3 kilograms, or kg. So milligrams to kilograms is it's basically 10 to the negative 6. So there's 1,000,000 milligrams in a kilogram. So that's why we would essentially be dividing by 1,000,000 to do that. So in the table form, because I've always done that in the past, it would look like this. So we've got milligrams. We want milligrams on the bottom. We want to end with kilograms. Milligrams is on the bottom so that they cancel. So 1 kilogram is 1,000,000 milligrams. So that's canceling 3 zeros, and then 3 more zeros would move the decimal place to 24.3. So still gives us 24.3 kilograms, whichever way you want to look at it. So what about this example from the book? The average ostrich weighs approximately 127 kilograms, pretty heavy. How many grams does an ostrich weigh? So again, with our prefixes, and after a while, you probably, writing and talking hard. It usually just becomes second nature after a while, like what these prefixes are. But so we're going from kilograms to grams, so that's going to be 3 units to the right. So another way of saying that is 1 kilogram is 1,000 grams. And so by the table, if we wanted to do it that way, 127 kilograms, and then we put kilograms on the bottom, we put grams on top. And so 1 kilogram is 1,000 grams, and so we're multiplying across, canceling the kilograms. And so that's 127,000 grams, which again is really just the same thing as starting out with 127. So 127, decimals at the end, move 3 places to the right, and every missing place gets a placeholder 0, and so it's still 127,000 grams for that conversion. So one more, how many milligrams are there in 0.25 kilograms? So we're going from a small unit of measure to a large unit of measure. So that is actually going to move us right? So we're going from kilo down to milli, and so that is 10 to the 6th. So what that basically means is we move 6 to the left. So 1 kilogram is equal to 10 to the 6 milligrams. So from the table, that's 0.025 kilograms. And then we want kilograms on the bottom, and we want milligrams on top. So a kilogram, and then 1,000,000 milligrams. And so this is moving the decimal place 6 places. So 1, 2, 3, 4, 5, 6. So that's going to be 2500 milligrams, because you're going to end up with here 3 placeholder zeros. Oh, that should be 3 placeholder zeros. That we have. So 1, 2, 3, 4, 5, 6. Yeah, so 3 placeholder zeros. So 25,000 milligrams is a kilogram, or 0.025 kilograms. So for a recipe for scones, calls for 350 grams of flour. So again, this is talking about weight of flour. You know, in the U.S. system, we typically talk about cups and we talk about teaspoons. We could also talk about like ounces, which is another measure of weight. And that's kind of what's confusing about the U.S. system, is things like cups, right, is really a measure of volume or capacity, as where something like ounces is a measure of weight, right? But here we're talking about 350 grams of flour. This is a measure of mass. This is how much of something you have. We're not talking about, you know, in the metric system, we would talk about cubic centimeters or cubic millimeters if we were talking about volume, which would be equivalent to cups. But this is talking about weight. But anyway, 350 grams of flour. How many kilograms of flour are required to make 4 batches of the scones? So if we're going to do 4 batches, we're going to have to do 4 times 350 grams. And so if you do that, do 4 times 350, then you're looking at 1,400 grams. And then to convert that to kilograms, you can just move the decimal place 3, and that's going to give you 1.4 kilograms, or kg, kilograms of flour. Again, if you wanted to see that in the table, I really like it just because it's so visual. So 1,400 grams, kilograms is what we want to end with so that the grams cancel, and 1 kilogram is 1,000 grams. So 1,400 divided by 1,000 is 1.4, and we're left with kilograms. So either way you slice it or bake it in this case, you're getting 1.4 kilograms to make these scones. So what about this example? It's another multi-step kind of word problem. The average tomato weighs 140 grams, and a farmer needs to order boxes to pack and ship their tomatoes to local grocery stores. They estimate that this year's harvest will yield about 125,000 tomatoes, and a box can hold 12 kilograms of tomatoes. How many boxes does the farmer need? So first thing we need to figure out is the total weight of the tomatoes. So total weight of the tomatoes is going to be 125,000 tomatoes times 140. Hang on. So 140 grams. So 125,000 times 140 is equal to, get my pointer here, 1. So that's 17,500,000 grams. Now our boxes are in 12 kilogram increments, so let's convert this to kilograms. Easiest way to do that is just move the decimal place 3. So we're talking about 2, the total kilograms of tomatoes is 17500 kilograms. All right, so 17,500 kilograms, and then a box can hold 12 kilograms. So finally, we want the tomatoes per box. And so that's going to be 175 kilograms per tomato. That's really not per tomato, that is per all the tomatoes. So 17,500 kilograms. And then we're going to divide that by 12 kilograms per box. And so if we divide that by 12, we end up getting 145, or sorry, got my decimal place off there. So 1458.3 boxes, which we would round up, because you can't have a fraction of a box. So this is what I would say the answer is. The book does say something a little bit, they'd round down. They just say 1,458 boxes. I would argue that you should round up, you should buy an extra box, because if it's only going to hold 12 kilograms, you know, you're going to need another box. So, but that is how you would work that out in finding how many boxes necessary to hold all. So that's it for this video. If you haven't already done so, read section 9.4, measuring weight. They have a lot more examples and some interesting videos in the book about converting units of mass, and the major ones, milligrams, grams, and kilograms. While you're reading the book, you should definitely be doing the Your Turn problems to check and see if you are mastering this material. The answer to those are provided at the end of the section. And then once you're done with all of that and you've taken some notes, complete the associated homework assignment inside of the Learning Management System.